Hi and Assalamualaikum. So the purpose of this video is for our Physics 210 assignment. We would like to present Chapter 4, which is Fluids. These contents are including measurement of pressure, Pascal's principle and application, buoyancy, and Archimedes principle. Without further ado, let's get started. Hi, my name is Nuraina Natasha binti Muhammad Firdaus.
Hi, I'm AZRA AQILAH binti HALIM.
Hi, my name is SYAZLEEN binti ANUAL.
My name is NURUL binti SUHAIME.
So this is our video content. First is measurement of pressure that will be presented by AZRA AQILAH. The second one is Pascal principle and application that will be presented by me, Nuraina Natasha. And the third one is buoyancy and application that will be presented by HANIS. And the last one is Archimedes principle and application that will be presented by SYAZLEEN.
Measurement of pressure. There are 4 ways on how to measure pressure. The first one is aneroid gauge. Second one is mercury barometer. The third one is open tube manometer. And the fourth one is tire pressure gauge. Okay, the first one is open tube manometer, and below is the example. In open tube manometer, the pressure in the open end is atmospheric pressure, and the pressure being measured will cause the fluid to rise until the pressure on both sides at the same height is equal. Formula: delta P equal to rho G delta H, and the SI unit is PA. Next is mercury barometer, and below is the example of it. The pressure at the surface of the mercury in the vessel is equal to the atmospheric pressure, and the formula is A equal to rho G delta H, where rho is the density of mercury. The final one is aneroid gauge. Aneroid means without fluid, and the term originally distinguished these gauges from the hydrostatic gauges described above. However, aneroid gauges can be used to measure the pressure of a liquid and gas. Here stated the 2 more devices for measuring pressure, which is the aneroid gauge and the tire pressure gauge.
So let's continue to Pascal's principle. Pascal's law is a principle in fluid mechanics given by Blaise Pascal that states a change in pressure applied to any point in a fluid at rest results in the same pressure change at every point in the fluid, meaning that pressure at X and pressure at Y is just the same. The formula of pressure is force of area. So as we can see, F1 over A1 is same with F2 over A2, meaning that the pressure at one point is same at another point. So this is the example of Pascal principle application. First is automobile hydraulic lift. Automobile hydraulic lift is used as a platform for a car or any heavier object to be lifted, like a truck, bus, or any other heavier object. In a hydraulic lift, a small piston is connected to a large piston. If we push down the small piston with the force that we call it F1, the large piston will be pushed upward with the force of F2. According to a Pascal principle, pressure exerted in a closed fluid is equal to every point. So it means that the pressure on the small piston is equal to pressure exerted on the large piston. So the second one is hydraulic brake, or the braking system in vehicles like cars, buses, or any other vehicle also work on Pascal's law. The hydraulic brakes allow equal pressure to be transmitted throughout the liquid. When the brake pedal is pushed, it exerts a force on the master cylinders, which increase the liquid pressure in it. The liquid pressure is transmitted equally through the liquid in the metal pipes to all the pistons of the other cylinder. Due to the increase in liquid pressure, The piston in the cylinder moves upward, pressing the brake pads with the brake drums. The force of friction between the brake pads and the brake drums stops the wheels.
First of all, we'll start with the introduction of buoyancy. Buoyancy is the force that causes an object to float. This force is applied by the fluid on the object, which makes it to rise up and is called as the force of buoyancy. The scale of this force is precisely equal to the amount of weight of the liquid displaced. As you can see from the visual here, this is P is the object and P on the blue region here is the fluid, and on the yellow side is the surface, upper surface of the fluid. Okay, as you can see, the buoyancy force is acting upwards towards the object, but on the upper side of the object, the gravity keeps pushing it downwards. So the buoyancy force and gravity force keep pushing the object, so the object keeps staying on the middle. So it's half submerged and half afloat. So that is the effect of force of buoyancy. Okay, moving on to the formula for buoyancy. The formula used is in this principle is called the Archimedes principle, which is buoyant force is equal to negative fluid density times acceleration due to gravity and the times fluid volume. The unit for buoyant force is Newton, and the fluid density and fluid volume is kilogram per meter square per meter cube, and the acceleration is meter per second. Moving on to the daily life application of buoyancy. First, we can see is from the boat. Second, from life jacket, and moving to submarine and buoy. From the boat, we can see that even though boat is actually heavy on land, but it's still able to stay afloat on the water, is because due to buoyancy principle. And for life jacket is able to save your life, because if you have any accident on boats and the boat is submerged, you need to stay afloat on the water so you don't get drowned. So you will not drown. Even though you can swim, you still need to wear a life jacket because you will exhaust yourself if you stay floating. And for submarine is one of the best example for buoyancy, because it can make itself submerge into the water or stay up on the surface of the water, because it have a special tank that is called as a ballast tank, that it can fill itself with water and make it heavier so it will submerge itself. But if they want to go up to the surface, they can release the water out of the tank and they can make themselves lighter so they can go to the surface. And for buoy is a sign that there is a light that used to signal the people on the boat, especially during the night, to signify how far they are from land and which way they were going, so they don't get lost in the middle of the sea. Thank you.
So lastly, we will talk about Archimedes principle. Actually, what is Archimedes principle? Archimedes principle deals with the force applied to an object by fluid surrounding it. This applied force reduces the net weight of the object submerged in a fluid. It is also this physical law of buoyancy that helps us understand how ships float in the water. Archimedes' principle also states that the upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. In simple form, the Archimedes law states that the buoyant force on an object is equal to the weight of the fluid displayed by the object. The formula written as F equal to rule GV, where F is the buoyant force, rule is the density of the fluid, V is the submerged volume, and G is the acceleration due to the gravity. So the application of Archimedes' principle that I choose is hot air balloon. The reason why hot air balloon rise and float in mid-air is because the buoyant force of the hot air balloon is less than the surrounding air. When the buoyant force of the hot air balloon is more, it starts to descend. This is done by varying the quantity of the hot air in the balloon.